So as Lewis said, I'm Neil. I'm Security Director at ForgeRock. We're a identity and access management vendor, so we do lots of things like OAuth 2 and those kind of things. And I'll be telling you a little bit our perspective on security issues that can crop up when you're using OAuth 2 and what some of the latest kind of best practices. So we're involved in the OAuth working group at the ITF, and there's some best common practice documents being written at the moment. And so this is kind of going to reflect some of those best practices that are emerging at the moment, which might be a little bit different if you're used to OAuth 2 from some of the things you might have been told in the past. You also might be able to hear that I'm full of cold today and my voice is going. I'm hoping I'm going to make it through the talk. Otherwise, it might be some sort of interpretive dance by the time we get to the end. Also, every time I've done this talk, it's overrun, so Lewis is going to throw stuff at me, I think, if I go too far. Right. So who here, show of hands first of all, who here is actually using OAuth at the moment, OAuth 2? Right, so a decent number of you. And who here is using, are those of you using OAuth 2, who's using it on a server side? So either as a resource server or as a client implemented on a server. Yeah. Who's using it on mobile? No, nobody. And anybody using it JavaScript client side, web app kind of stuff? Right. Okay, so there's a bit of, I've got some introductory slides on kind of OAuth 2 for those who don't know anything about it, and then we'll get into some of the things that can go wrong and some of the security best practices. So what is OAuth? So its original problem it was solving was, how do I let other third-party apps and sites and things access some of my data on, you know, Facebook, Google, whatever, or my email account, without just giving them my username and password. So, you know, a common pattern before then was that you just literally go and type in your username and password for Facebook into some other app, and then it would do stuff on your behalf, which is kind of a terrible idea, because then it can just do whatever you can do. So OAuth then was a protocol that was originally designed for delegated authorization. So I'm already authorized to access my stuff, and I want to just give a little bit of that authority to some other app. You know, so maybe it can view some of my photos on Facebook or something. So OAuth 1 first came out in around 2007, wasn't standardized until 3 years later. OAuth 2, which we're going to talk about in this talk, is the current version, which was standardized in 2012. So still quite a while ago, you know, over 6 years ago now. And now there's tons of extensions to OAuth 2. People are using it way beyond its original use cases, so it's used outside web, on mobile, Internet of Things, microservices, things like that. And it's being used beyond just sort of delegated authorization that it was originally for. So things like OpenID Connect, which is a extension on top of OAuth to do authentication, and then UMA, User Managed Access, which does all kinds of authorization. So for those of you who don't know OAuth 2, the basic idea of it is what we call the OAuth 2 dance. So you've got this nice smiley happy resource owner, that's me, who wants to use some other client. So it could be a mobile app, but it could be a website, it could be, you know, some service, to access some of my stuff which is on a resource server, an RS. So these are the terms used in OAuth. And so I want to be able to delegate some of my authority to this client. So in OAuth, to do this, we introduced this new role known as an authorization server, or AS, which is going to handle this delegated authorization on behalf of the resource server. So what the client does is, first of all, it says, I want to have access to this user's stuff. And it also includes in that a scope, which is just a set of strings which say, you know, what exactly it wants to have access to. And so that might be, you know, I need read-only access to these group of photos, or I want read-write access to this folder in your shared Google Drive or whatever. The authorization server is then going to talk to the resource owner. It's typically going to authenticate them. You know, they'll be logged in and have a session with the authorization server. So this is typically a redirect in a web browser. So the client redirects the user in their web browser to the authorization server. That's going to log them in and then say, you know, is it cool that this app accesses all your stuff? The resource owner says yes, and so the authorization server issues an access token, which is a limited scope token that the client can then use to access your stuff on the resource server, and it never actually sees your credentials at all. So that's the basic idea. There's a bunch of flows then on OAuth 2. So everything of OAuth 2 is sort of pluggable and extensible in various ways. So the easiest flow is what's called the implicit flow. So when that authorization is completed, the authorization server redirects back to the client, and it just gives it the access token in that redirect. So typically it's in the URL fragment, and then you can use some JavaScript or whatever to pull that out of the fragment. Or you can also put it in a query parameter, or you can now use things like form post. So the authorization server will create a self-submitting form that then posts the access token back to the endpoint. So it's purely redirect based. There's then a slightly more secure flow known as the authorization code flow, which rather than including the access token directly in the URL, in the redirect, it returns a one-time authorization code, which can only be used once, and then it can never be used again. And then the client then makes another call directly to the authorization server, so not going via redirect, to swap that code for its actual access token. And that means that if somebody does happen to steal that authorization code, it's hopefully already been used up by the time they try and use it, and it can't be used again. And then there's another one called a refresh token flow. So the authorization server, as well as giving you an access token, might give you a refresh token, which allows you to then get another access token later when your one has expired without bothering the user again. So you can just go back to the authorization, your client can go back to the authorization server and say, right, my access token has run out, I want another one with the same scopes that the user already approved, and it will just give you another one. And that means the authorization server can issue tokens with a more limited expiry time. So if we look now at particular best practices in different scenarios, so if you're implementing a resource server, so if you're, say, Flickr or Google or somebody who's implementing this and wants to protect resources with OAuth 2, so what's the kind of things that can go wrong, and what are the best practices? So first of all, how does the client send you the access token on a request? So there's kind of four main choices for HTTP. You can put it in a URL parameter and just pass it in, so the client calls into your thing and just passes it in a URL parameter. You can put it in a cookie. You can put it in the body of the post or whatever request it's making, or you can put it in a header. So those are the kind of the main things you could use in HTTP. So most of these have drawbacks. So a URL parameter is just a terrible idea, so don't ever do this. URL parameters get logged everywhere. So when you talk to a service, typically in the cloud, you're usually it's not just your client talking directly to their server. There's usually loads of boxes in the middle. There's proxies and load balancers and all kinds of other things. And a lot of them will end up logging URL parameters in their access logs, which means that any administrator or anybody who has access to those logs has got your access token then. So this kind of leaks everywhere. And then also things like referrer headers. If you redirect somewhere else or load something else, sometimes these URL parameters can leak in the referrer header as well. Cookies are kind of, you can secure cookies quite a lot now. There's quite a lot of attributes you can set on cookies to make them only over TLS, and same site cookies to kind of prevent some of these things. But you've got to be aware of issues like cross-site request forgery and things like this, which are kind of generic to cookie usage. But then also now as well, browsers and extensions and things are getting more aggressive at kind of blocking cookies. So if you use cookies for your client to call resource servers, if you're doing it in a browser, then those cookies might be blocked on requests, and so it's not a very reliable way of doing things. And finally, postbody is kind of better, but it mixes your access token, then is in amongst all your application data for that request, and it's kind of a separate thing, right? You're mixing your authorization with your data, so it's kind of could be better. So what generally most people advise is to use the authorization header. So this is standard in both. So HTTP has the standard authorization header. You can use if you use basic auth, for instance, you can use that. And OAuth has standardized this bearer auth scheme. So you just have authorization, bearer, and then your access token, and you can send that as an extra header. Also, HTTP, if you don't supply your authorization, there's a standard header for the resource server to prompt you for it, this www authenticate, where you can say, yeah, you need an access token with these scopes to be able to make that call. So this is what we'd always recommend. So all of these kind of middle boxes and caches and things that you go through, they all, because it's standard, they all know about it. They all know not to log that in their access logs because it contains credentials. And they all know, for instance, the cache knows that if something's got an authorization header on a request, it's, something is probably private and I shouldn't cache that publicly. Very forbidding. And again, if you're a client running within a browser, then using this, because it's a non-safe header, it triggers these same origin policy protections, which are quite important for the whole web security model when you're running in a browser. So wherever you can, always try and accept access tokens in the authorization header. So then once you've got an access token from the client, how do you actually validate it? So first of all, you've got this notion of a scope, which you can find out for the access token. And what does that actually mean? And should this request be allowed with access token with a certain scope? And really, scope is just completely unspecified in OAuth 2. There's a few standards that formalize some scopes, but it's a set of strings that make sense to your resource server. And the way to look about this is a scope is a decision you want a user to make about granting consent. So if you look at, say, Google, the way they organise their scopes, if you look at Google Cloud Platform, they've got loads of OAuth 2 access for all their stuff. And their scopes, they have a scope per service, a really granular thing. So if you want to use Google Key Management Service, one I've been using recently, there's just a scope which is just Key Management Service, right? It's the whole thing. And there's a scope which is like all of Google Cloud Platform. And they only break it down into individual scopes when it's to do with user data and something a user might care about. So when it's accessing a particular user's files on Google Drive or something, then they have lots of fine-grained scopes to because a user wants to make that decision about what they're accessing. Validation is also mostly unspecified in the OAuth 2 spec. So the original spec, it was just like, you must do validation. But it's up to the authorization server and the resource server to agree how they're going to do that. And so there were kind of various ad hoc approaches for this. There's now a new RFC for token introspection, which kind of formalizes this, so you use that if you can. So this just allows the resource server to itself register as a client with the authorization server, and then it can call an endpoint and say, here's an access token I just got given, is it still valid, who is it issued to, what are the scopes associated with it, and so on. And you get that back in a nice JSON format. So one popular choice early on was to have the access token be assigned JOT to JSON Web Token. So this is a self-contained thing that the resource server can then just look at that. It's got a signature on it. It trusts the signatures from its authorization server, so it can validate that signature, and then it can look in it and see various claims about who this was issued to, what scopes is it for, who was the resource owner that authorized it, all those kind of things. When does it expire? So, but the problem then, if you're using these self-contained things, how do you revoke them? If an access token could live for quite a long time, if the user decides he doesn't like this app anymore and doesn't want to keep using it, he wants to revoke that access. In this model, when the access token is self-contained, how do you indicate that that token should no longer be trusted anymore? So one answer that's been popular with lots of people would be to issue short-lived access tokens. So you set a specified maximum time you want to wait for revocation to happen, and then you issue a short-lived access token. And then the client, has to use this refresh flow instead. So the client has to keep going back to the authorization server and saying, give me a new access token, give me a new access token. And that gives a time for the authorization server to say, no, it's been revoked now, so I'm not going to give you another one. And so, your access token is now expired, so you can't use it anymore and your access has been cut off. So what's the problem with this? I call this the fallacy of the short attack window. So how long, if you're following that kind of model, how long should you wait? How long do you want to wait maximum before you realise that an access token has been revoked? If it's up to the client to go back and keep refreshing, do you issue them an access token that lasts for minutes, for hours? Because for them it's inconvenient because they've got to add new network traffic. If you're talking about a mobile client, if it's refreshing all the time, it's using battery power, making extra network requests. And if we look at a recent attack on OAuth, so I don't know if any of you know there was an attack against Facebook's OAuth implementation back in September. They had this feature in Facebook where you can write a Facebook page and then you can view it as if you are one of your friends, and you'll see the page rendered as they would see it if they were viewing it. And the way that worked behind the scenes in Facebook was that they generated kind of limited scope access tokens as if you were a client and your mate was the resource owner, and it kind of approved them. And this was all supposed to work, that these were so limited scope that you could only just view that one page of it. And through a series of bugs, it turned out that one of the access tokens they were issuing for, I think it was for a video player component, had the full power of the same access token they would issue to their own official Facebook mobile app if you were logged in as the other user. And so that was like a full session token basically for that user that you could do almost anything with, including authorize yourself access tokens for any apps that were linked to Facebook. If you've got login with Facebook linked to your third-party app, you could then authorize another access token for that. And then you can also use that access token to then view as all your friends as well, and their friends and so on. And so you could kind of expand the attack and just keep getting access tokens for more and more people. So when Facebook, I think they noticed this pretty quickly actually, and shut the attack down. But their own assessment was that around 50 million accounts had been affected by this, and they revoked around 90 million access tokens afterwards as a kind of precautionary measure. And this was a highly automated attack. Somebody figured out it was working, and then they wrote code, effectively scripts and things to do it on a highly automated basis. So it was just compromising accounts. So if you think about that in terms of this short access token lifetime pattern, how long was each one of these tokens used for? I reckon if you're doing the math, that it was very short amount of time. Certainly if you're waiting minutes or hours, then that's probably already far too long for somebody to do these kind of things. So the takeaway from that really is that short lifetimes, they're still a good idea, but you shouldn't be relying on this as a kind of primary way of protecting things. And that really, even if you're using these kind of self-contained access tokens, you want to be thinking about doing things like token inspection anyway to check if they've been revoked, and having your authorization server be able to tell you that. And looking at some additional protections, which we're not going to cover much in this talk, but things like there's things like proof of protection and token binding and things which you can look up. So, question now: Are we done? So we've got this access token, we've got it in a header, we've validated the scopes, we've checked it's not expired. What else do we need to do? So we forgot one thing here. Does the resource owner themselves actually have permission to do the request that this client is doing on their behalf? So this is something people seem to forget about with OAuth sometimes. They see authorization in OAuth and they assume it's kind of it's as sufficient on its own for authorization. But you've got to remember, the original design of OAuth is delegated authorization. It assumes that your resource server already has a way of authorizing its own users, and you're delegating some of that to somebody else. So you've got to check as well. Does the resource owner that authorized this access token, would they actually have permission to perform this action? So this is something people seem to forget reasonably often. So it's not okay to just validate your access token, validate the scopes, and then go, all good, right? Because you know, if you have like an admin scope, say, and a user who's just any old user can just grant an access token with admin scope, you've got to check that they are actually an admin, right, to perform actions for administrators. So, I mean, you can make OAuth work this way. You can arrange with your authorization server to kind of interpret scopes as permissions and do all these kind of things, but it's not the default, and you have to kind of consider this aspect. So also as well, when you make that initial authorization call, the authorization server in OAuth, it doesn't know anything at all about what you're going to use that access token for or who the resource server is. There's no indication in that request of where you're going to use this. And so it's very hard for it to actually make any kind of authorization decision at that point. Again, you can work around this. You can say, I'm going to have unique scopes for each of my different services, and so I know by looking at the scopes. But you're kind of going beyond OAuth then and kind of implementing something on top of it, which is fine, but just be aware of the issues when you're doing that. And then related also, you know, if you're relying on an access token to tell you whether somebody should have access, you've got to think that, you know, as we were just saying, access tokens can live for a long time, especially with refresh tokens, really long time. Does the resource owner who authorized it in the first place, do they still have access? You know, if they're an employee and they've, say, granted an app access to your internal payroll system or something like that on their mobile phone, say, you know, and they then leave the company, right? Are their access tokens still valid in this app, right? So this is what's, you know, a time of check to time of use bug. So always make sure that you're always checking whether the resource owner that issued the access token would still have permission to do whatever they're doing. So the easiest way to do this is to check the access token, check everything on it, and then carry out the request as if the user was doing it themselves through your normal application. So you apply all the same checks you would do if they were just using your own internal app. Right, so OAuth, you know, even though it's got authorization in the name, it's about delegated authorization. So you can build more stronger authorization models on top of it, but that's not what it's primarily designed for. But see UMA, user managed access, has a much more kind of fleshed out notion of what authorization actually means and builds on top of OAuth too. So moving on from resource servers, we'll look at mobile clients next. I don't think anyone was doing mobile clients, but we'll look at mobile clients because a lot of the best practice advice now is now sort of applying to other clients as well. So what do we used to recommend for mobile clients, right? They'd register with the authorization server as a public client. So what we're saying here is that a mobile app can't keep a secret, so it can't be what's called a confidential client and have its own credentials. The reason for this, we're not saying that your phone can't keep a secret. You know, they've normally got various secure elements and things, but it's the actual app that you download from the App Store. If that was a confidential client, it would have somewhere baked inside it a client secret, and everyone would get the same copy of the app, and any one of those people can unpack it and read the secret. So we consider mobile clients to be public clients, and that's kind of industry standard approach. So they don't have any credentials, and so we kind of rely on a unique callback when they get redirected back from the authorization server is the main way that the authorization server is kind of authenticating this app. And it used to be the case that we'd recommend that you use a private use URL scheme. So com.example.app, you know, rather than HTTP, whatever, you use a private URL scheme, and then your mobile app then registers that with Android or iOS or whatever, and then when the browser redirects back, it's going to the operating system is going to hand over that to your app to handle that redirect, and you can get your access token. And a lot of mobile apps in the old days as well use the implicit flow because it's one less network request, and so it's easier on battery life. And then another thing was quite common early on was to spawn the OAuth2 request. You'd render a web view within your app. You know, within your code, you just use the HTML widgets within iOS and Android, and you'd render that, and the user would do the flow, and then come back to your app. So what's wrong with this? So there's a few things wrong with this. So this is my brilliantly drawn depiction of a mobile phone. And here's an authorization server redirecting back with a custom URL scheme, which the operating system is then handing over to that app. The problem with this is that custom URL schemes are not enforced to be unique by the phones. So multiple apps can register the same URL scheme. In fact, that's quite common for multiple apps from the same organization to register the same URL scheme. And that means that a malicious app could potentially register your same URL scheme, and then they potentially could get handed your access token. If they're installed on the same device, if they're the only app installed on that device handling that scheme, then they'll just get the callback straight away. It depends what happens if there's multiple apps. I think on Android you get like a chooser, but you know, the malicious app is going to make itself look as much like the genuine app as possible. So you may end up with your callback with your access token going to a different app and then being used to do all kinds of nefarious things. And finally, that use of the in-app, so rendering your own web view and doing that is kind of a poor practice. You remember back at the start we were saying the whole point of OAuth 2 was to stop giving your credentials to third-party apps. Right? If you're rendering your own web view and getting them to type their username and password into that, you know, it's not really a lot better, right? Your app can still steal their credentials out of that web view. So the kind of best practices that are emerging. So there's an RFC now, which is called a best common practice for native apps, which covers a lot of these recommendations. So you always use the system browser to initiate flows. So just this, you know, don't render your own thing. It's kind of teaching users to type their credentials into individual apps. This is also nicer for the user because, you know, if you've already logged in your system browser, then all your session cookies and stuff are still there. So it's kind of a smoother flow as well. And you can get it now to look like, you know, almost as smooth as if you were rendering your own embedded web view. Secondly, so there's Android and iOS both support something called iOS calls them universal links and Android calls them app links. And this means instead of using a custom private use URL scheme, you can claim some portion of your actual website HTTPS address space and say, if my app is installed on the phone, any redirects to, you know, google.com/app will be handled by that app. And so it will claim it. And the reason this is better than using a private use URL scheme is because in both of those cases, then your web server has to publish a special document to a certain place, whitelisting the IDs of the apps that are allowed to claim its address space. So a malicious party can't do this. They can't unless they compromise your web server. They can't do this. So their app doesn't get to claim your address space, and so they don't get to handle your redirects. And finally, the best practice now is to just always use the authorization code flow. You know, it's one extra round trip over the network, a bit more battery life, but security-wise, it's got a lot more to go with it. And use something called PKCE, which I'll talk about in a moment. I hope you all recognise this amazing band here. So PKCE, what is PKCE? PKCE is Proof Key for Code Exchange, and it's a way for public clients who don't have credentials to beef up the security of the authorization code flow and stop some attacks. So with the authorization code flow, you still have this authorization code is still being kind of exposed in the redirect when you come back from the authorization server. And although it's one-time use, you know, an attacker could get there first and use it before you. If you're a confidential client, then you get to authenticate on that request and stop those kind of attacks. But if you're a public client, you don't have any credentials. So how do you get around this? And PKCE is the way that's been kind of standardized to get around this. And it's a really great flow, so you know, use it. But the way it works is it just adds a couple of extra steps. So the first thing the client does before it starts its flow is it generates this random verifier, which is just a 256-bit random value fresh every time. It just generates that and it holds on to that, so we'll call that V here. Then it makes its request to the authorization server and includes an extra parameter here, which is this code challenge. And the code challenge is a secure hash of the value. There's another version where you just send the value, but use this version. So it's a secure hash of the value, and because that's a kind of unguessable value, nobody can reverse that hash. So if anyone observes that, they can't work out what V is from just seeing the hash. The authorization then carries on as normal, goes through its flow, issues an authorization code as normal, and then there's another step then when you go and cache in your authorization code, you pass in the code you got, but you also pass in a code verifier, which is the original unhashed value you generated at the start. And what this means is that with all these redirects and everything going backwards and forwards, you've proved that you're the same client caching in the authorization code that you were at the start, that initially started it. So the authorization server is going to check that by hashing the verifier you've just sent and checking whether that's the same as the challenge you sent in the first request. So it's kind of simple. Lots of client libraries now for OAuth 2 support PKCE out of the box, so you don't even have to necessarily do this yourself. So there's a library called OAuth for mobile phones that just implements this flow and a lot of these best practices. But it's pretty easy to implement yourself if you're doing OAuth. So if everything checks out, you get an access token as normal, and you can use that to access the resource server. So moving on from mobile clients, we'll whiz through web clients. I've had my 5-minute warning already. So server-side clients, again, use the authorization flow. This has been the advice from the start. A server can keep secrets, so just use the authorization code flow. It's a confidential client, so you can authenticate to the authorization server, which means that the authorization server is not going to let anyone else cache in your authorization codes. But there's still a few things that can go wrong. These are kind of things that might go wrong, but are quite, the server side is still pretty secure, so don't worry too much about these. So we'll whiz through these. So credential theft. A lot of people don't realize, so the client secret you get as a confidential client looks a bit like a password, and you'd kind of expect that this would be hashed on the authorization server. But actually loads of parts of the OAuth 2 spec require that the authorization server be able to access this in the clear. So there's things like the client, there's extensions that allow like a client to send an encrypted request, which is encrypted under that client credentials. So the server needs to be able to know those client credentials in order to be able to decrypt it. So in a lot of authorization servers, client credentials are usually just encrypted and not hashed. So they are recoverable in the event that the authorization server got compromised and that encryption key got compromised. So it's a minor thing, but something to think about. There are more secure means of authentication you can use. So there's a thing called private key JOT, where you can register a public key with the client and then you sign a JOT to kind of authenticate rather than using a username and password. And then there's mutual TLS, which is kind of being standardized at the moment, which would allow you to use a TLS client certificate to authenticate your client. So there are potential things to think about. And then there's also something, so while somebody couldn't steal your authorization code because of the credentials, they might be able to inject one. So this is kind of a weird attack, which is quite hard to pull off. Somebody could start a flow against your server-side app as themselves, stop it when the authorization code comes back and sort of block that request and take that authorization code, and then they might be able to inject that into somebody else's session and swap out the authorization code. And because the client credentials are all going to match up, that will still be a valid authorization code for the client, but it will end up being for the wrong user. And so you might end up with a situation, say, where your photos you're uploading get uploaded to the attacker's account rather than your own account. This is a very hard attack to kind of pull off. There's lots of other protections in OAuth, but if you're worried about it, just use PKCE as well, because PKCE completely stops this account, this kind of attack as well. So even though you're a confidential client, you can use PKCE too. So client-side web apps and single-page apps. Old advice is use the implicit flow. you can't do any better in a web app. So there's various things that can go wrong. So a malicious script that happens to be running in the same context as your web page can sniff access tokens from the URL. Access tokens can leak. So if you're using the fragment, this is kind of okay, but like if you're using the query parameter redirect thing, like I said before, don't put stuff in query parameters. It can leak in logs and in document referrer. So even if you're loading third-party scripts in an iframe, the document referrer contains the URL of who the parent frame that loaded that iframe. So if you've got an access token in that URL, not in the fragment, then they'll be able to see that. And secondly, you can do the same kind of token injection. So a malicious script could swap out your access token and put in their own one and get stuff saved to their thing. Finally, if you redirect on somewhere else, then if you don't explicitly clear the fragment, then it can end up getting included in the redirect. So there's one huge change since OAuth 2. So OAuth 2 was published in 2012. Right, there's a thing called CORS published in 2014, which I'm sure web developers here will all be familiar with. So cross-origin resource sharing is a way of allowing a web client to make requests to different domains. So previously that would just be blocked by the same origin policy in a browser. So you wouldn't be able to make, so if your authorization server is on a different domain to your client, you wouldn't have been able to make a direct call to it to cache in an authorization code. But CORS allows this now. So you can use the authorization code flow in a browser. And that is the new advice coming out in best common practice, is to start using the authorization code flow and PKCE in a browser. Again, just like for mobile, public client, so just use auth code flow and PKCE. So if you can't move off implicit, so lots of people have been using implicit for a long time, what can you do? So first of all, don't panic. These are not new exploits that are kind of in the wild. They're things that could be better with implicit. And we're kind of, now that CORS exists, we're trying to harden things up a little bit and encourage best practices. So normal web security best practices, loading third-party code in iframes, sandboxing them, those kind of things, go a long way to kind of stopping attacks against implicit. And there's some extra things you can do I won't go into because I think we're in danger of overrunning. So OpenID Connect has some various protections that can make it harder for some of the attacks against implicit. There's a thing called the JOT secured authorization response mode that has been standardized by financial services, which allows the entire request and response to be assigned JOT that's kind of integrity protected and stops people messing with things. And then there's this idea of what are called sender constrained access tokens, or proof of possession, where you can tie an access token to a key that only the client has, and then every time it uses the access token, it proves possession of that key, which makes it a lot harder to steal an access token. So, summaries then. Pretty much across the board now, the recommendation is to use the authorization code flow. So even if you're in a browser, a mobile, server, the implicit is likely to even be deprecated or at least strongly discouraged by the OAuth working group quite soon. Use PKCE. It's a great band, great flow. Even for confidential clients, it adds something. It's really simple. It's, in my opinion, one of the best things that's been added to OAuth 2 in the time it's been out. Use the authorization bearer header. Think about authorization rather than just delegation. And finally, these are the drafts that are in progress in the working group. So if you want to go and Google these are things to look to. So there's a general OAuth security topics, best common practice, and then there's a draft for specifically for browser-based single-page apps and things. Okay, right. Didn't overrun too much, did I?
No, thanks, that's great talk.
Excellent.
So we got time for questions. Adam's helping us out today with a microphone, so all talks are being filmed. So anyone have any questions? Oh, so Neil, if you could repeat the question as well.
Okay.
Can you say something about using OAuth 2 for authentication and the difference between authentication and authorization?
Right. So the question was to talk a little bit about using OAuth 2 for authentication rather than just authorization. So OpenID Connect is the standard then which kind of builds on this for authentication. If you think about what you want with authentication, you want to know that a particular user is there doing something at that time, and they're there right then. OAuth 2 doesn't really guarantee that, because you can give an access token to a service that then works on your behalf in the background, right? So there's no guarantee that a user is actually there at the point. In OAuth 2, technically, I'd have to go and read the jargon, but I'm not even sure OAuth 2 guarantees that the resource owner is actually authenticated, right? They're just required to give their consent to the delegation. So OpenID Connect kind of builds on top of this and adds a lot of extra features you'd want. So it kind of has much more of a kind of what you get back is this extra token called an ID token, which is supposed to be a short-lived kind of proof that a user was actually authenticated right there and then. And you also get things like, how were they authenticated, right? If you're saying something like, I want every user that uses this particular resource to be authenticated with two-factor authentication, right? You can say that in OpenID Connect. You can't really say it in OAuth 2. You can arrange with your authorization server that that's a policy that you apply all the time. But if you're logging in with Facebook, right, you'd have to be quite a big company, I think, before you could go and tell Facebook that all the users are going to be authenticated with two-factor authentication. Whereas OpenID Connect allows you to kind of specify these things in the request and say, right, I want them authenticated with this particular level of assurance, and then you also get more details back about them as well. So there used to be, early on, before OpenID Connect, there was a kind of ad hoc standard people did where you would do an OAuth 2 flow with a particular scope, and then the client could then go and access the user's profile on the authorization server as a kind of proof that they were authenticated and get some details about them. But the problem was then any other client that could ask for the same scope could then turn around and send their access token to you. And unless you were very careful about checking that it was issued actually to you, then that client could pretend to be the user. So OpenID Connect sort of solves all these issues. An ID token has an audience and an issue and stuff in it that you can check, and there's very specific checks you have to do. So.
Any more questions?
Hi, thanks for a really interesting talk. I'm not a web developer, or more from a network security side. Mm-hmm. And when you were showing the flow for PKCE, mm-hmm. Where I'm proving I'm the original requester by sending the unhashed V for the authorization server to hash it and prove I am them. Yeah. If I've already conducted a successful man-in-the-middle attack at this stage, so if I'm sat on that blue line, what's to stop me forwarding that on with the correct V value that's sent in the clear, and then just not giving the token back to the client, going and using it with the resource server myself? So
think about what this is kind of trying to protect against is the things like the private use URL scheme. So the authorization code being kind of transferred in a non-secure way within the operating system of the mobile client. It might go to the wrong thing. So the actual network requests, OAuth 2 specifies they all have to be over SSL. So they all have to be HTTPS. So we're kind of relying on the network layer security to prevent that man-in-the-middle attack at that point. So it's kind of protecting against threats within the client itself. So if you're running in a mobile phone, something else being able to snoop on your access tokens. If you're running in a browser, third-party scripts being able to snoop on things like that.
Okay, that makes sense. And I take it that trust that TLS or SSL is there is the same as the trust with the OpenID you were just saying of OAuth just assumes that you as a developer have done that.
Right, yeah. There's an explicit requirement in the OAuth 2 RFC that all communications happen over HTTPS. Okay. yeah, it even specifies a minimum version of TLS as well, I think, at some point.
Okay, thank you.
Hi, thank you. I was going to ask, on the resource service, the permission can be given at certain level, not the full admin access, but certain sources or apps in there. Can you put more levels on it and record it?
So, I mean, in terms of the scopes and things, I mean, that's entirely up to your resource server to decide what those scopes mean. Like I said, the way Google does this is that they normally, when you're accessing Google services, you're normally using a service account unless you're dealing with user data. And then their scopes are just like, this service account has access to this service, and then they set permissions at the level of the service account below OAuth 2 to say, right, and within, so the scope might be key management service, and then the service account, which is the resource owner in their flow, itself has permissions locked down to, this can only, it can sign stuff with this key, or it can read that key, or whatever. And so they kind of, if a user's not making a delegated authorization permission, they set permissions in a traditional way, using like role-based access or permissions underneath, and then they look at their access token, look at the scope on it as a first check, then they see which resource owner authorized that access token, and then they do traditional authorization based on that, who that user was.
Any more questions? Cool. Well, thanks again, Neil. That was great.